welcome to the Astute Engineer, part 2. Had some interesting feedback from the first one, so I'll try to watch my language. Rich, introduce yourself. You've been around the industry for some time.
Quite a long time, longer than perhaps some would like, but yeah, over 40 years now in electronics. So started off in engineering and sort of moved into battery charging manufacturer, transformers, basic electronics, some of the older style military standard type electronics, and then moved into distribution and then into power supply manufacturing. And after quite a few years, ended here at Astute.
How long have you been here now?
8 years, coming up to 8 years this year. Yeah, 8 years in May.
Wow. Okay. Yeah. So you just come back from Embedded World out in Nuremberg, big engineering show. What was the topic of conversation?
Obviously several as far as Astute are concerned, but as far as I was concerned, it was more about USB-C charging and also some of the battery technologies that we're engaging with through various partners. And they were fascinating topics to a lot of people, so we had some really good leads.
Okay. The USB-C charging, Pulsive, got their product to market now?
Yeah, we as Astute are the first company in the world to have the 65-watt USB-C charger that can work in wall without overheating, meets all of the building requirements, all the safety specs. And Astute now have the opportunity to take that to market, particularly in Germany and in the UK. So very exciting times for us. It's a very exciting product. We had quite a few power supply manufacturers interested while we were at Embedded World as well. So
okay. Don't take this wrong way, but exciting for you in power. But what does it actually mean in layman terms? What's this going to change?
It's a very good question. Power supplies historically have not changed much over the years. Like I say, 30, 40 years ago, pretty much the topologies remain the same. Where I think it's changing now is that a lot of semiconductor microcontroller manufacturers are pushing a threshold in terms of efficiencies, and Pulsive is one such company. They've come out with a unique technique to improve efficiency, reduce size, and that's kind of where we're going. So as far as power is concerned, I would say it's probably some of the more exciting things that have happened, some of the more exciting changes.
Okay, so, I mean, I've spoke to you many times about this product and we're all excited about it. I hope it does deliver. Is it going to get impacted with all these tariff issues?
Yeah, actually, I had a conversation today, and the supply chain, you know better than me, but I'm getting feedback from some power supply companies that lead times are already going out, and a lot of that has been down to really companies stock holding or holding, trying to grab hold of stock already in fear of any sort of shortages. And a lot of that has been because they're scared of the tariffs coming through and they want to try and safeguard the future supply chain. And that's had an impact on the initial samples that we were supposed to be getting from Pulsive. So it's just thin edge of the wedge at the moment, but yeah, I think.
And at Embedded World, I'm sure the topic of conversation must have been around tariffs and people's concerns.
It was, yeah. It's not so much anything I got involved in so much because I kept to the technical aspects of it and left the commercial stuff to the more experienced people in that. But certainly, yes, tariffs were a topic of conversation from some of the prime customers that we saw there, for sure.
I actually read a very good report by Z2 Data, gave it to one of our young marketeers. Hopefully she reads it, but who knows. But it was interesting when you actually look at this 25% impact that's been imposed. $140 billion of semiconductors with US country of origin gets exported. I mean, that's
incredible.
That is going to have a major impact. And I think anyone who buys electronic goods, cars, whatever it may be, even down to the module you're talking about, repulsive. How are we going to overcome that?
It's a pretty good question. I think the advantage I could say, as far as power is concerned, is a lot of older technology. So you could argue that power is not going to be affected quite as much as perhaps the processing side of things. But I think as far as the manufacturers are concerned, in the semiconductor side of the power side, I'm really not sure. I get the feeling people like TI and other leading technologies like that are putting lead times out. People are forward ordering. Pulsive are already doing that now today.
Well, it's interesting. Deeper into the report, it talks about what components are impacted. And passives are quite heavily impacted as well, with the imports into the US, because a lot of the Asian manufacturers for the passives. But microcontrollers must be a big issue.
I'd imagine so, for sure, yeah. I did hear anecdotally with a lot of companies, Chinese-based companies, are moving manufacturing out into the Philippines, to Vietnam, Thailand, to try and get past the impact of tariffs, I think, just to try and bypass that sort of attitude or that fear of sourcing Chinese product. But I think that's going to take time.
It is. I mean, the Semiconductor Chip Act signed by Biden is starting to have some impact. We're going to get some wafers built in the US, but it's not going to be for another couple of years. So, I mean, I'm with you. I think the impact's going to be strong and hard when it hits. People are trying to adjust to it. But power covers a whole different range. But battery technology, now that does interest me.
Yeah, me too.
Not because I've got a Tesla, because I don't. But that's going to have a massive impact as well there, isn't it?
Yeah, it is. I mean, certainly the tariffs, it's already telling. And, Mark, obviously you do a lot of work in Australia. You have a lot of contacts out there. And we have been talking to partners and people manufacturing in Australia. And there is a lot of technology moving in Australia that's using in-country content rather than importing content that way. And I think that could be a way that people will bypass the issues coming out of material from the rest of the world.
You're making reference to the 6T?
The 6T battery, yeah, absolutely that. But not just that, but the energy storage, the battery storage systems that these companies are now using. They're trying to get as much in-country content as they possibly can. It makes it marginally more expensive, but in terms of the green aspect of it, if you like, it's a very attractive proposition.
Okay. Talking about green, we've got a young team, very concerned about the environment, as Astute are. How long does a battery last? I mean, Tesla's, there must be end of life coming for those batteries.
Yeah, potentially, of course, and the impact of fast charging is something to be considered. And battery technology's got to change. It's got to adapt. And Tesla and a lot of the car manufacturers started using lithium ion. And we know lithium ion environmentally is not fantastic.
When you say not fantastic?
Well, there's a couple of materials, nickel and cobalt, for example, are materials that it has an impact on the environment by mining it, by using it. It's not in fantastic supply, let's say. But if you move to a different technology or a different lithium technology, such as lithium iron phosphate, you don't need those materials. You're using phosphate and iron, which is a little bit more plentiful, let's say. So, and also it has a less impact on the recycling aspects of batteries. So although you perhaps lose a little bit in terms of its overall capacity, in terms of how many times you can charge, discharge, It's better, it's more resilient, it's safer, it's a more stable battery technology. And in terms of, I guess, the environmental aspects of it and the mining and the building of them, lithium iron phosphate, I would say, is becoming more prevalent.
Okay. And it's interesting talking about the actual mining of, and we all know with Democratic Republic of Congo, what's going on there, where a lot of cobalt comes from. But I did a little bit of research on ChatGPT.
Okay.
So I didn't really do it, but it was interesting. I just asked a question on, when do they start degradation and how long do they last? And they talk about 100,000 miles on average, 8 years to 100,000 miles. And company car drivers, I know we don't see as many customers anymore, but that means we should be getting a big landfill site of old batteries. What happens?
Yeah, actually on the landfill side, if we are sensible, and we should be, we would actually recycle it rather than landfill. The thing about lithium is it can be recycled. You can break them down. You can break lithium batteries down, reuse the material and rebuild a battery. It may not perform as well as it did originally, but you could use that for example, for renewable energy. So attach it to the grid, for example.
Okay.
So you could reuse or reutilize older lithium cells. So I guess a message to the younger generation, or any generation really, is...
You mean Ben?
Yeah, absolutely. But you would definitely look to... don't throw away the lithium cells, even as coin cells, anything. Recycle them. They can get broken down. They can get reused, and I think environmentally that's a good thing.
That's encouraging. But also, and I'm thinking I've only learned this from you, but there's some developments in hydrogen fuel cell. How's that?
Yeah.
What is the difference?
Well, the material it uses, of course. So you create a gas with hydrogen. I'm not an expert at hydrogen fuel cells. I wish I was. I think it's an exciting topic and technology. It has its challenges in terms of the infrastructure of how you create the gas. But we're, as you know, dealing with some companies that are leading that technology in hydrogen fuel cells and using them actually to replace diesel generators in remote sites, for example. But also to a smaller extent to actually use them for UAVs as an alternative form of energy there. I think it's got a long way to go. I think there are challenges in creating the propulsion using hydrogen fuel cells, but it's getting there. JCB in the Midlands already have some of their plant equipment running off hydrogen fuel cells and have been very, very successful. And if you look at it in a raw light of day, a hydrogen fuel cell or a hydrogen propelled vehicle, is more economical in a lot of ways. It does more miles, so typically you could get over 400 miles per refill in a car, for example. It takes very little time to refuel a vehicle with hydrogen, as opposed to sat in service stations or petrol stations and charging for an hour or so. But of course, like anything, we don't have the infrastructure to get the gas to garage forecourts, for example. But that could come. But I think it's something that, we have to adopt and get used to. And in fairness, there's only a few car manufacturers such as Toyota that are coming out with hydrogen-run cars, but they're there and they're working.
Okay,
so.
I didn't know it moved forward that far. So, one of the other topics I'm sure that was discussed at Embedded would have been what's happening in the conflicts around the world, especially with the Ukraine. Defence spending is being reconsidered by most of European governments. Where's that trending?
Yeah, that's a good question. Again, we did have a lot of conversations with some of Astute's prime customers. for us, of course, this change, this direction, this increase is obviously going to be good in a couple of ways. One, it means that we can push more new technology, perhaps to the primes that we talk to, which is interesting for us. I think as well, I think it looks good for employment, for bringing on new engineers, young engineers into this sector. So I think, as much as it's a negative that we have to put an increase in defence spend, in one sense it's a stable, as we know, it's quite a stable market to get into, and if we can use that to improve technology, maybe look at greener vehicles, greener defence vehicles or devices, then that's all good. I kind of look at defence sometimes as a bit like Formula One is to the automotive industry. Sometimes defence comes out with a technology or a technique that is kind of out there and ahead of its time, and then filters down into, let's say, the more sort of commercial aspects of it. A little bit like Formula One, ABS systems moving into cars. So it'd be good to be able to push younger people into the defence sector.
Let's move away from defence for now. Before we go down a route we can't go back
exactly.
But you make a good point about the young engineer, and we all know there's a skill gap. We sat on a couple of working groups over the years, and there's two generations of young engineers that haven't come into manufacturing. Engineering isn't sexy as it was back in your day. So how do we encourage youngsters to look at what engineering can take them?
Very good question. I don't think I have an answer for that. It's I think the good thing today is the day-to-day technologies that we use, from cell phones, anything that's renewable. There's some really exciting technology out there, and if we can get people to engage in how to take that technology further, then maybe that's the way to do it. But we live in a very digital world. I've come through an analog world with power. Power's classed as analog. People are more interested in the clever aspects of things, the software side, let's say. And I think the industry has got to look at pushing younger people through university to get excited about electronics and building the base products rather than just using secondary items. But
I guess my question was more framed with, I didn't know about engineering and certainly power before I met you, and over a beer, of course.
Always.
I actually get quite excited about some of the developments. I mean, Syncor, one of your key lines, and what they've done with the MPFIC. Looking at challenges, I know that you've got some things to do where you're looking at drone technology, but it's actually the rate and speed of change and development, that's still exciting. So it must excite you.
Yeah, absolutely. And it's a prime example of in our industry, in our sector, drone technology is moving forward. Again, without getting into the sort of conflicts and stuff, we have seen a change in how that's going to go ahead. I think what's happening in the Ukraine is showing that it's a whole different ball game now. And recently, Astute were at Exponential in Dusseldorf. Very, very interesting show. It's predominantly about drones, but not just for defence. Actually, drones are being used in emergency areas, in emergency situations, where you can have a drone that's tethered to the ground. It sits on top of a roof of a vehicle, for example, ambulance or whatever, and then it just allows rescuers to search the area for any kind of victims and stuff like this. And when you look at technology like that and the uses that it has, that is exciting. Yeah. And then you sort of kind of think, well, what do you want to do? You want to push the thresholds of what that drone does. So you'd be looking at things like making them fly longer, for example. So how do you do that? Well, you make them lighter, you make them more efficient, so they can stay up there longer, so they're of more use to the user. And that's where we've got to try and get younger people to engage, to get them excited about it and to push those thresholds. And then maybe create something that nobody else has really done. And Syncor, as you mentioned, is one of the best, if not the best, manufacturers of power modules in the kind of mil-aero sector. They recognise this, and they are pushing these DC to DC converters to be able to work in that kind of environment. So, yeah, I am really excited about it. Syncor recognise the direction it's going in and are developing new products that we're kind of getting our teams around the globe to engage with customers. So yeah, it's good stuff.
So where does it go to next? Where do you see it developing?
I think it's enhancing. It's enhancing current technology. I think batteries are playing such a massive part in all of our prime customers. You mentioned 60 batteries, for example, for vehicles. So moving from lead acids to lithium, there's distinct advantages. We look at drones. Drones will fly on batteries. There's a lot of technology that we look at today that where we rely on batteries. You mentioned energy storage, either off the grid or even if you've got deployable stations. We know diesel generators are a problem, so we want to move to battery technologies. So that's great. We have the battery technology. We can look at different battery chemistries to improve that. But what we're seeing now is semiconductor manufacturers working out, well, how can we make these batteries last longer? How can we get them to charge faster without damage? How can we get them to have more battery charge cycles? So the more you charge a battery, it starts reducing in its capacity, basically. But if you can actually improve that, it just means your end use for any product massively increases, almost fourfold. So if we can get younger people who are engaged with this type of technology, like I say, from a mobile phone to any kind of device that they use, even drones that you would use, sort of socially rather than, for any particular purpose. The frustration is always that you want it to fly longer and last longer. And when you're going out and you're kind of filming something, you don't want to be having it to dock it down and recharge it all the time. So if we can get people to sort of work on technologies and methods of improving that, one, it's great for the environment. Two, things last longer, so it becomes cheaper. And three, we can maybe get some engagement on new technologies in engineering.
It's interesting. A lot of things we discussed, you're just talking about big units, but electronics are everywhere, power's everywhere, wearables.
Yeah.
So there's more and more need to keep tech going. So,
absolutely.
You talked about fuel cells earlier. Where's that going? How does that develop?
Yeah. I don't know how we can implement fuel cells or hydrogen fuel cells in terms of creating energy. I think that could be a way of saving energy, or our problem is the amount of energy we need to create to keep everything is going from like you say, your wearable watch to heating element, heating in a house and so on. That all takes energy and power to create that. So you either build a load of power stations and increase wind farms, solar, or you create more efficient ways of using that energy. So you almost maintain the amount of energy that you have, but you make it more efficient. And if you can save 5-10% of energy that's currently used by improving efficiencies, then you don't have to build so many power stations and so on. So in the power industry, that is a big driving factor. And even a 0.5% increase in efficiencies in, let's say, cloud storage data centers, it's a phenomenal saving, just 0.5%. And that's where we've got to go.
Yeah, and I think when you talk about data centers, AI is everywhere.
Yeah, absolutely.
But that drains a lot of power.
Indeed.
So we need to find a way of being more efficient there. I mean, there's no doubt about it. So, you have been in the industry for, what do you say, 140 years?
Yeah, 140 years.
What advice do you give to young engineers today? I'm fresh out of university. In fact, I don't even know which direction I want to go. What do you give advice? What's your snippet?
I think if you've got a passion or a belief, and it might be as simple as that you want to be an environmentalist in a way, try to look at technology and how you could engage with that technology to maybe drive your dreams to a more environmentally friendly society. And we all know the more energy you create, the worse it is for the environment. So rather than rather than perhaps plant a tree or maybe stop using something else, well, why not see if you can take that excitement that you have about the environment, and you try to look at it from a technological point of view. And that's probably the best way of looking at it. I am considerably older than most in this industry, so I kind of fell into it because it was a job, it was a career. I didn't do it because I was passionate about power. When I went into the power supply industry, it wasn't because I thought I've got to get into power, but I kind of made it a career. I made it a passion. And actually, I would say since I've been at Astute, technology has kind of moved. You know this, Mark, because we've worked together on Syncor. We've seen Pulsive come through. We've both talked about battery technologies for the mil-aero sector. So I would say since I've been here 8 years, I think power has changed. I think it really has changed.
I agree. I mean, for me, you're almost framing it that, try to channel that passion they have for the environment into making power more efficient.
Yeah.
And if you can do that, everyone wins.
100%.
I mean, it's fascinating. I'm not going to even try to make out and know what's really going on with the power division, but it's certainly exciting. So I was going to ask you a question about what you was drinking, Embedded World, but I thought best not, because you're on a health kick.
I'm on a health kick,
and you're looking good for it. But so one book that you would advise a 21-year-old Rich Ford to read that would change their life, what would it be? A book, not a magazine.
Right.
Leave that top shelf.
Controversially, I would say there's a really, really good book for any young person to read and going forward in life, and that is Why Men Don't Listen and Why Women Can't Read Maps. Look it up. Very much, it's a very good book. It's slightly humorous, but actually, do you know what? I think it can change relationships with people quite seriously. And I've introduced it to quite a few people at various exhibitions over the years of all different cultures. And all have sort of called me back and said, you know what? That translates in Chinese, Turkish, African, American and European people. We're all fundamentally the same. And it's an enjoyable read, and it's written by a man and wife, psychologists, and they've written it together. And if we can all follow that, I think actually the world could be a lot happier place.
Yeah, good point. Which one doesn't read the map? Which one doesn't
I'm
listen?
not saying that. I probably overstretched the mark a little bit already on this one, and there might be some comeback on it. But, no, I think I enjoyed the book. I read it later on in life, and I wish I'd have read it earlier. It's a fun book. A little bit Mars, men are from Mars, women from Venus.
Okay.
but in a more informal way. But fundamentally, yeah, it's good. It's good life stories in there.
Good. Well, thanks for your time.
No problem.
Always good to catch up with or without a beer.
Yeah, less beers these days, but
Thank God for that.
yeah,
Suffered the pain for that.
Calming down.
Yeah. Right, Rich Ford, head of our power division, knows everything we need to know about power. Thanks for your time.
No problem. Thanks very much.
Thanks for listening again. We're learning. Any feedback that you've got, please give it to us. If anyone's got any tips at Cheltenham, because that's another loss I've just had. Follow us on Instagram, LinkedIn. Not going to mention any other social media outputs. So thanks again. See you again soon.